All right, so today, last new notes for the year, we are going to be adding and subtracting fractions. So that's our objective, to add and subtract algebraic fractions. For starters, we are going to add and subtract just some normal fractions with just numbers, no variables involved yet. So on all of these fractions, what do we notice that makes it easy for us? The denominator is already the same. Now, we have not had to worry about our denominators being the same before. You don't need that when you multiply or divide, but you do need a common denominator for adding or subtracting. What's nice is that they already gave us a common denominator. So, on number 1, my denominator is going to stay 8. And to get my numerator, what am I going to do? Subtract. 5 minus 1 is 4. But what do we know about this new fraction that we've got here? We can reduce it. What does it become? 1/2. So that's our final answer. We reduce our fraction to 1/2, and we're done with it. Number 2, again, we have a common denominator. So can anybody just tell me my answer for this one? 4/3. Can that reduce? No. I am not worried about you changing these into mixed numbers. Just leave them as improper fractions. It's less work, and that's how I prefer it anyway. On warm-up number 3, Keon? Disagree. Closer. Ryan? -5/7. Good. So we've got 1 minus 6. That gives us a -5. Denominator stays a 7. Can that reduce? No. So we leave it alone. All right, so these rules for addition and subtraction of fractions is really what we just talked about. So you would need to fill in this piece right here. Same thing for the subtraction. It's just showing that you keep your same denominator, the C in this case, and you either add or subtract your numerators from left to right, whatever operation they put, either addition or subtraction. For the examples, they worked most of it out for us. They showed us that if we take 2/9 plus 5/9, that's the same as 2 plus 5 over 9. So our last step would just be to rewrite our numerator as 2 plus 5 is 7, and my denominator would stay 9, the same. All right, similarly with our example for subtraction, we've got 4/5 minus 1/5 is the same as 4 minus 1 over 5. 4 minus 1 gives us 3, and my denominator is still a 5. So our note says if two fractions have the same denominator, just keep the denominator and add or subtract the numerators. So on number 1, what's my denominator going to be? 16. It's going to stay the same. And in my numerator, what am I going to do? Add 3c plus 5c. If you want to write that out as its own step, you can. 3c plus 5c over 16. That step is not entirely necessary on ones like this. What do we get when we take 3c plus 5c? 8c. Should it be squared? No, we only square it when we do what operation? Multiply them. So we're just combining like terms. It can just stay a plain old C. But what do we notice about this? It can reduce to what? I agree about the 1/2 part, but what are we missing? The C. So it would be 1C over 2. If you don't put the 1 in front of the C, that's fine. It could just be C over 2. Either one of those would be acceptable as a final answer. So what's nice about today is that you are always going to be given common denominators. When you get to Algebra 2, then you'll learn how to handle it when they're not common denominators. But for now, they will always be common denominators. So what is my denominator going to be on number 2? X plus 3. What's happening in my numerator? Adding what? X plus 4. Now this is one where I would recommend just writing that out. Is there anything for me to combine? Is there anything for me to reduce? No. Why can I not reduce those x's? So if you need to or want to, you could put parentheses around both of these to remind yourselves that those are stuck together, and they could only be canceled out if there was another set of parentheses that matched it perfectly. That's why we talked about simplifying last week. So this one cannot be simplified. Can it be factored? No, there's nothing to factor from it, so really that is just our final answer. Nothing about it can change. All right, next examples. Again, we are starting off with a common denominator. So for number 3, what is my denominator going to be right now? 5m plus 25. For now, we can leave it that way, but you might notice that that denominator can be I haven't heard my favorite word, factored. Thank you, Deja. That denominator can be factored, so we might want to keep that in mind for later on. You don't necessarily have to do that right away. And in my numerator, if I were to write out my whole numerator for right now, what's going to be in it? Okay, we're adding our two numerators. So m minus 6 plus m plus 3. Again, you don't necessarily have to write it all out like that, but I would recommend doing that on these longer problems. What do you think we need to do in our numerator right now? Combine like terms. M plus m would give me, no, 2m. Remember, if we're just combining like terms, our exponents don't change. What about negative 6 plus 3? Negative 3 over, now this might be a good time to go ahead and factor that denominator. What can we factor from it? We can factor out a GCF of 5. Remember, your GCF is written outside of parentheses. Whatever's left over when you divide goes inside those parentheses. So what's left over? M plus 5. Okay, is there anything I can factor from my numerator? No, so you could just put parentheses around it to remind yourself that it's stuck together as a binomial. Will anything cancel out or reduce? No, Nothing can cancel out here. The parentheses don't match. There's nothing on top that can reduce with the 5 because it would need to be outside those parentheses. So that is our final answer. All right, moving on to number 4. Let's just leave our denominator alone for right now. We know that we've got a common denominator. So for now, we'll keep it, but we'll think that probably on our next step, we'll want to factor it. In my numerator right now, what's happening? What operation are they wanting us to do? Addition. So I'm adding these two numerators. N plus 3 plus 4n plus 3. When our numerators get added, we can do what to simplify it? Combine like terms. N plus 4n is 5n. 3 plus 3 is a positive 6, so plus 6. In my denominator, what could I do? I can factor out what for my GCF? 6n, good. When I factor out a 6n, what is left over? N plus 3, wonderful. Now, is there anything that I could factor in the top? No, so we could just put parentheses around that to remind ourselves it's a binomial. Is there anything that will cancel out here? No, so we are finished. Questions, concerns about number 4? Are we sure? Okay, moving on. What's different about number 5 from the ones that we've done? We got a trinomial in the denominator. I like that math language. But again, it matches, so for now, we'll just keep that same denominator. We should be thinking, though, that sooner or later we're going to have to do what to it? Factor it. Good. All right, in my numerator, what's going on? Addition. So I'm going to be taking x minus 4 plus 5x plus 3. So what do I want to do in my numerator? I'm not ready to factor my numerator. Numerator's the top. What am I wanting to do in my top part for my next step? Combine like terms. X plus 5x. 6x. Negative 4 plus 3. Negative 1. In my denominator, what do I want to do? The x method to factor. What goes on top? On bottom? My numbers that would fill in those sides. Negative 6 and negative 2. Good. They both got to be negative if we're multiplying to a positive. All right. We use that to factor our denominator into what two binomials? Good. X minus 6, x minus 2. Will the numerator factor? No, so we can just put our parentheses around it. Will anything cancel out? No. So that is our final answer. We ready to move on? On we go. Maybe. There we go. All right, our next note. If two fractions have the same denominator, just keep the denominator and subtract the numerators. When subtracting, you will need to distribute the negative into the numerator of the fraction. Now, I wish that said the numerator of the second fraction, but I think it'll make more sense when we see a problem. All right, on 6 and 7, they go back to starting us off pretty easy. We've got a common denominator. It is not one that could be factored. So in my denominator, what am I keeping? 12. In my numerator, what am I doing? Subtracting. We have 3x minus 5x. That gives me a negative 2x. And then what could we do from there? Reduce it. What would it become? Close. Good. Negative 1x over 6. That is the same thing as just negative x over 6. So either one of those would be acceptable. Questions about 6? Okay. On 7, my denominator is x minus 5. That whole thing stays my denominator. In my numerator, what am I doing? Subtracting 2x minus 3. Careful. Can I do anything with that? No. Are they like terms? No. Can it be factored? No. So if you need to put parentheses around them to remember that they cannot reduce with each other because they do not match, that's fine. But other than that, there's nothing I can do. Questions about 6 or 7? All right, moving on to some more interesting problems. Now, number 8, we look at that denominator and we say, well, thankfully it's the same. So for now, we're going to keep it, but in the future, we're probably going to want to factor it. In my numerator, what am I doing? Subtracting. Now this time it's a little bit different from the last ones because we are subtracting a binomial. So we're going to have 5 minus, I'm going to put in parentheses the m plus 4. When we're doing addition, I did not write parentheses around my second numerator, because addition does not change any signs anywhere. But if we are subtracting, remember that note said that we would have to distribute the subtraction or negative sign into the fraction. This is what they were talking about. So I would always put parentheses around my second numerator, even if you want to do it from the very beginning, to remember that you have to distribute a negative or a subtraction sign before you can combine your like terms. So on our next step, let's do that. The 5 stays the same from that first numerator. If I take negative times m, that's going to be minus m or negative m. And then I'm taking a negative times a positive 4. It's going to change it to be negative 4. So really it's just going to change your signs from your second numerator. While we're at it, we can go ahead and factor that denominator. What do we get? Anybody factor it yet? Good. M minus 3 and M minus 4. If you need to see that magic X, we would have had 12 in the top, negative 7 in the bottom. That's why we used a negative 3 and a negative 4. Now we're not done, because what can we still do in our numerator? What can I still do in the top here? What can get simplified up there? Okay, the 5 and the negative 4 can be combined. They are like terms. So if I combine a 5 with a negative 4, what do I get? A 1. So you could either write this as 1 minus m with the same denominator, or you could write it as negative m plus 1. The m was negative, the 1 was positive. You could keep it in a binomial if you want. I'm fine with the 1 minus m, but if you really want your m to be written first, that's how we would have to do it, negative m plus 1. Now, either way we write this, nothing's going to simplify or reduce, so we are just going to leave it alone there. On number 9, we've got a common denominator, so we'll keep it for now. In my numerator, what operation am I doing? Subtraction. So my first numerator, I'm just going to rewrite. I'm going to put my minus sign in there. My second numerator, I'm putting in parentheses for now. This helps me remember that I have to distribute my negative sign into those parentheses. If you don't distribute the negative sign through and you only give the negative to that V in the front, then your sign on the 3 will end up wrong. So that leaves me with V plus 4 minus V. What sign will end up on the 3? Plus 3. Okay, so it just switches the signs around for us. Now you could either factor your denominator now, or you can wait till the next step. What do you want to do? Now or later? Go ahead and do it now. What can I factor from my denominator? 30 as a GCF, and what's left? V minus 1. Good. All right, on my next step, it might be my last step, I don't really know yet. On my next step, what do I need to do? Combine like terms in my numerator. So my denominator I'll leave alone. In my numerator, I have V and a negative V. What do those do? They cancel each other out. A positive and a negative of the same thing cancels out. So I'm left with positive 4 plus 3. 7. Will the 7 and the 30 reduce with each other? Nope. So that is my last step, final answer. If we'd gotten a 6 instead of a 7, then we would have wanted to reduce it. But 7 does not reduce with 30, so we are finished. Questions, concerns? Okay, we'll keep on going. Maybe. There we go. Last one. Just flying through these. My denominator is the same. I like to see that, so I'll keep it for now while I think about my numerator. What operation do we have going on? Subtraction. Do I need to put parentheses around my second numerator? No, because it's only one term. So there's really no distributing that we have to do when it's just one term. Does that make sense? Okay, it gets a little tricky with subtraction. But if it's just a monomial in our second numerator, we can just put minus whatever it is. So that means on my next step, I can do something with my numerator and something with my denominator. Let's start in the numerator. What can I do? Starting in the top. Combine like terms. X minus 2x. Negative 1x. Or just negative x. Is there anything I can do with this plus 2? Nothing to change it, so yes, we just add it on to the end. What can I do in my denominator? The x method to factor it. What goes in the top of my x? The bottom. On the sides? 1 and 3, which means this factors to be what? Beautiful. Seems like we're doing really well with our factoring. That's good. Is there anything that's going to cancel out or reduce here? No. This negative x plus 2 is a binomial. Does not match any of my other binomials in the bottom. So we're going to leave it the same. Questions, concerns?